Here we have a tricky GCSE problem to look through. This is from Edexcel June 2022, paper 1H, and it's the final question of the paper, question 21. The diagram shows 3 circles, each of radius 4 centimetres. So the first thing I'm going to do is label that somewhere, just so I know and I don't forget. So this I'm going to call our radius, and that's 4 centimetres. The diagram shows 3 circles, each of radius 4 centimetres, so they're all the same size. The centres of the circles are A, B and C, such that ABC is a straight line, and AB equals BC equals 4 centimetres. Okay. Work out the total area of the 2 shaded regions. Give your answer in terms of pi. Note it says here the total area, okay, and as I said before, our radius is 4 centimetres, okay. So the approach to this question is the top and the bottom of these 2 are going to be identical, okay. So if we can find out just the size of one of these and then times it by 2, we'll have the answer that we're looking for, okay. And we can calculate the size of a segment of a circle. So in this case, if I grab my ruler and put it at 60 degrees. So this point here has a distance r, okay? And this point here is going to be a distance r. If I get my ruler again. And basically, if we think about dividing up the circle, we can calculate the size of this region. Okay, that's like we can calculate the size of that, and it's basically going to be an equilateral triangle, because if we find the third size, this distance is also going to be r, because that's the distance from B to its radius, okay? So these are all r, which means that this angle is 60 degrees. 60 degrees, okay? So this shaded light blue region makes up 1/6 of the total area of the shape, okay? And I'll show you why. We've got here 60 divided by 360 times pi r squared, okay? 60 over 360 is 1/6, because if you can divide both by 10, and then you've got 6 over 36, and then divide those both by 6, you get 1 over 6, times pi r squared. R is 4, as we wrote down earlier. So that means that this is going to be 16 over 6 pi. And this will simplify. If we divide both by 2, because they're both even, we get 8 over 3 pi centimetres squared. Okay. And this, I'm just going to do a little drawing next to it. If we have B and C, and then we have roughly that sort of shape, okay? So that's what we've calculated there. We can also find the area of the triangle, okay? Because let me talk through what we're going to do. We found this area. We found the area, the light blue shaded area. If I just change pen real quick. We want to find effectively the 4 little sectors like this, or segments. These little segments, so there's 4 of these in red, and then in green we've got these triangles that we're trying to calculate. And if we can take all of this combined, and then we take that away from the area of 1/2 of the whole thing, so I'll do that in yellow, that's going to be this whole area here. That will leave us with just the shaded area, which is what we're looking for. So hopefully that doesn't look too messy and you're still with me. Let's go through it. So we've currently got this segment which includes the triangle and the little sector at the edge. So we want to get rid of that triangle so that we can we need to find the area of the triangle regardless. So we've got our equilateral triangle, and each side has a distance of 4 centimeters. Okay, and for the area of a triangle, we need a half base times height. So it's going to be a half BH equals the area. So the base is going to be 4 centimeters. And we need to use Pythagoras' theorem to calculate the height, which is going to be like this. Okay, so to calculate h, we can think of this as the hypotenuse, which is 4 squared, minus 2 squared, which is half of the base, because we've basically got, I'll change colour again, we're doing this length here, and we've got this length here. So if this is C and this is B, you can think of this as A if we're using Pythagoras' theorem. So we're doing C squared minus B squared, all square rooted, to find A, if that helps. So we're going to go through this. That is going to turn out to be the square root of 16 minus 4. And then that's the square root of 12. And then using our knowledge of surds, this is square root of 4 times the square root of 3, which is the same as 2 root 3. Okay, 2 root 3 equals h. Okay, now we need to find the area. So we do a half times the base, which is 4, times the height, which is 2 root 3. And this gives us 4 root 3, because it's basically 2 times 2 root 3. And then this is the area of the triangle, where we have B and C. Okay? So now that we have the area of the triangle, we can find the area of just the sliver, which would sort of look like this. Okay? This is going to be 8 over 3 pi. And this is going to be units of centimeters squared, by the way. 8 over 3 pi, which is the in fact, I'll draw this out. So we're basically doing the entire sector like this, minus the area of the triangle equals the segmented area. Okay? So if we write that down, we have 8 over 3 pi minus 4 root 3. Okay, and we can't simplify that any further, and that's our segment area. Now, we know there's 4 of these, the ones shaded in red, and there's also 2 triangles. Okay, so we're going to first add that all up. And to give you a visual idea of what I'm doing, we're basically calculating we will be doing half of a circle minus basically the 2 crescent bits on the inside. So this is our bit that we're calculating right now, and then that will leave us with just one of these, this area, the area we're looking for. And we obviously need 2 of these, but this is the start. Okay, so here we're going to have a half pi r squared, because it's half of the total area, minus, we have 4 of the slivers and 2 triangles, so we need to do 4 times 8 over 3 pi minus 4 root 3 minus the area of 2 triangles. So if I do that in a different colour, you can probably see. So we're doing 4 of these segments, okay, and then we also have the 2 triangles in the middle. Okay, so the triangle is 4 root 3, which I'm just going to double check. Size of the triangle is 4 root 3, and now we just need to expand it all. Okay, And remembering this is one of what we're looking for. We need to double it at the end. And I'm just going to go back and change r squared, we know is 4 squared, okay? This is equal to 16 over 2 pi minus 32 over 3 pi plus, because there's a minus sign here, plus 16 root 3 minus 8 root 3. This is equal to 8 pi minus 32 over 3 pi plus 8 over 8 root 3. 8 pi is the same as 24 over 3 pi minus 32 over 3 pi equals minus 8 over 3 pi. So what we have now, once we simplify this, is 8 root 3 minus 8 over 3 pi. Okay, but remember, as I said earlier, we need to double all of this. So we're almost there. 8 root 3 minus 8 over 3 pi times 2 equals 16 root 3 minus 16 over 3 pi centimetres squared. And that's our final answer. Okay, let's give it a look and see if that's correct. Okay, so now I have the mark scheme in front of me. We can give it a look. So it looks like I've got the correct answer, which is 16 root 3 minus 16 over 3 pi. That's good. So we can see that this would be A1, because this is what you get for 16 root 3 minus 16 over 3 pi, which is what I have. And it says OE means or equivalent, okay? First mark is for identifying an angle of 60. That is exactly what I did here. So that would get me P1. Okay, and that's also evidenced in this bit here. So that's P1. Then the process to find the area of a sector of angle 60 or 120. So you can see we have pi 4 squared times 60 over 360 equals 8 over 3 pi, and that's what I've gone for. So that would be my mark there. It would be P1 also, obviously the second one now, because I used this equation here. Then P1 for process to find the area of an equilateral triangle. As you can see, I did half base times height. This is where I then get my next mark, because I've said that that's my area of my triangle. Okay, and that is, you get the mark for trying to find, in my case, the area of the equilateral triangle. Then final mark for using area of sector minus area of triangle to find area of segment, and that's what I've sort of showed visually here, and then I sort of go on to show later on. So you can see the key answer you need is 8 pi over 3 minus 4 root 3, and that's what I have shown there. So that would be another mark. And they also show you how they did that, which was by doing the area of the sector and then subtracting the area of the triangle. Okay, so full marks for me, 5 out of 5. There are also some other options you could use that are shown on the mark scheme. So obviously I went with the first approach, which was to find this segment here, but you can actually use different methods. So this segment would be 120 degrees because you've got the two equilateral triangles put together. You can think of it as this being our equilateral triangle, and then if one of these is 60, two of them is 120. So if I move those, you would do pi r squared times 120 over 360 would be a third. So you can see how you'd get that following a similar method. So you'd find the area of that whole segment. Once you found the area of what the shaded area, you can times that by 4, as they've shown down here, 4 times the area of the segment, and subtract that from the area of the circle, and then you have your answer. Here, they also said you could look at the shaded area directly. The same shaded area that we had earlier, you could take away 2 of these from one triangle, and then you'd have one area. Oh, sorry, not from the triangle, in fact. If you had the area of the segment, include it, so this whole thing here, and then subtracted the 2 smaller bits, you'd have the half of the total answer. So you can see they go on to explain that in the bit following. So hopefully that was all helpful. It's a bit of a nightmare of a question, but hopefully this makes it nice and clear. Alright, good luck. Thank you.